Hello, okay, today we're going to do a lesson on polynomials, okay, in A Maths. Okay, this lesson is for
Do you want to build a snowman? Come on, let's go and play.
Okay, so over here, let me introduce to you what are polynomials. Okay, polynomial is actually is this an English word? Christy, is polynomial an English word? You don't know. Make a guess. No, it's not. Polynomial is actually a what word? Come on, Mandy, it's a what word? It's a Greek word, right? It's a Greek. That's why every time I say polynomial, you don't understand. You know why? Because you don't understand Greek. Right? Polynomial is actually a Greek word which means many terms. Okay, which means many terms. So we're going to study. We're going to do some study on this topic of polynomials. First of all, I need to introduce to you what is a polynomial. Okay, if you were to write something like this, 3x plus 5. Everyone here, you know this expression. In set 1, set 2, we always call this. Oh, girls, take note. These are over here. You see two terms, right? You see 3x and then you see the number 5. Am I correct? So these are algebraic expressions, algebraic terms. You are correct. But because there are two terms, so we call them polynomials. Okay, polynomial, which means many terms. But girls, please take note. A polynomial does not simply just mean that there are many terms. Even if, let's say, I just write the number 8, this is also a polynomial. Okay, so what exactly is a polynomial? Okay, watch. I'm going to write something for you over here that is not a polynomial. For example, this, my friend, this is not a polynomial. This is a polynomial. This is a polynomial. This, make a guess. Is this a polynomial? Yes or no? Yes. Yes, this is a polynomial. This is a polynomial. This is a polynomial. This is not a polynomial. Okay? Another example that is not a polynomial example. This is also not a polynomial. Okay, based on the examples that I give you, the variety of examples that I give you, are you able to tell me now roughly what you think is a polynomial? Okay, I give another example of a non-polynomial. Okay, example. This is not a polynomial. Okay, is this okay? Another example. This is not a polynomial. Okay, so based on these examples, can you tell me roughly what do you notice are some characteristics of a polynomial and what are not polynomials? Okay, Sinead, tell me. So for a polynomial, what do you notice about its power?
Cannot have a fraction.
What do you notice? So the power, if it cannot be a fraction, it must always be a whole number. Very good. Another word for whole number, Hannah, is? Another word for whole number is? Integer. Very good. Take a look at this. Let's try again. Is this a whole number? -2, -2. Is this a whole number?
Yes.
Okay, that is a whole number. But I shared with you that 4x to the power of -2 is not a polynomial. So even though the power is a whole number, is an integer, it is also not a polynomial. So can we be a bit more specific for the power in order for an expression to be a polynomial? So other than whole number, it must always be what?
A positive.
Wait a minute. Must it always be positive? What about 0? Let's look at this particular situation. The number 8. This is a polynomial. The number 8 is actually 8x to the power of 0. Am I correct? 8x to the power of 0. The power is actually 0. So is it a polynomial? I told you, yes, it is a polynomial. So if you want to be very specific about what is a polynomial, okay, our understanding must be non-negative. Okay, the power must be a non-negative integer. Okay, non-negative integer. So write it down. Okay, so I've already explained this, that over here this 8 is the same as 8x to the power of 0. So this is a polynomial. Over here, this is 5 square root x plus 4. This is the same as 5x to the power of half and then plus 4. Over here, if you take a look at the power, over here in this case, this is 5x to the power of half. That's why this is not a polynomial. Okay? Over here in this case, this is 8 over x plus 4x squared. 4x squared is the polynomial, but 8 over x. This expression is 8x to the power of negative 1. So this makes it not a polynomial. Okay? So the same with this, 3x to the power of 2/3, because it's 2/3. This is not a whole number, therefore it is not a polynomial. Same thing for 4x to the power of negative 2. The power is negative, so it is not a polynomial. Okay, let's take a look at this particular example. This is the function px, okay, is equal to 2x cubed minus 3. This is a polynomial because 2x is to the power of 3. Over here, this is a qx, is also a polynomial because it's 4x minus 1. Okay, the power of x over here are all non-negative integers. I want to ask you a particular question. If I take px plus qx, can you tell me what is for the resultant polynomial, right? The final answer, right? What is the highest power of this polynomial? It will be, everybody? 3. Very good. If I were to subtract, I take px, the function px subtract qx, tell me what will happen to the highest power in the resultant polynomial. It will be also 3, right? It will also be 3, right? So over here, right, if I ask you another question, let's say if I throw in rx, I don't know what's rx, okay? I don't know what's rx, but let us say it is cubic in nature. Okay, let's say this is cubic in nature. So now I'm going to ask you, if I were to take px plus rx, okay, what can be my highest power in the polynomial? It will be 3. Okay. What if I do subtraction? Must the highest power always be 3? Yes or no? Yes or no? No. Why not? Because, give me just one example. I let rx be what? Talk to me. Let rx be 2x cubed. Very good. Example, this is 2x cubed. If I take px minus rx, what will happen? 2x cubed minus 3 minus 2x cubed. What will happen? 2x cubed minus 2x cubed. This is minus 3. So the x cubed can disappear. Am I correct? But what am I trying to illustrate here? The key point I'm trying to illustrate is when you do subtraction or addition, right? The highest power will never cross the highest in that particular situation. If here the highest power is 3, it will never exceed 3. It can go lower than 3, but it can never go higher than 3. Is that okay? So far so good? Sometimes to copy down whatever you need on the board. Okay, one thing you can take note Mr. kept mentioning the highest power in the polynomial. Okay, there's a term for this. There's a term for this. The highest power in the polynomial is actually called the degree of the polynomial. D-E-G-R-E-E. Okay, D-E-G-R-E-E. When I would say something like the degree of a polynomial, what I'm referring to is actually the highest power that exists in that polynomial. Okay? So if I were to take a look at this particular expression px, I say, what is the degree of polynomial of px? What's the degree of polynomial? The highest power in this px is actually 3, right? So the degree of the polynomial will be 3. Over here we have qx equals to 4x minus 1. If I were to ask the class, so what is the degree of polynomial of qx? Can you tell me what is the degree of polynomial of qx? It will be 1. Is everybody clear? Okay girls, so now I want you to try to expand this particular product of these 2 polynomials for me. Okay, you expand it first and then later I want to zoom in on some things. Okay, I'll get somebody here to do it for us. Okay, great. Okay, thank you very much, Putri. Thank you. Okay, so over here, right, can I have a show of hands? How many of you, when you expand, you have this? Raise your hand. Thank you very much. Okay, over here, right, okay, what's the purpose of doing this? If I were to ask you a particular question, okay, instead of expanding, okay, now I know the answer is this. Instead of expanding everything, if I just want to look at the product of these two polynomials and I say, what is the coefficient of the x cubed? What is the coefficient of the x cubed of the resultant polynomial? When you multiply them, I only want to find out the coefficient of the x cubed term. Will you do this? Most of you will do this, am I right? Most of you will expand everything and then expand till the cows go home. Then after that, then you realize, so it's 11x cubed. Therefore, the coefficient of x cubed is 11. Yay! You are correct. But how long do you take to get this? A very long time. Is there another way of doing this? Answer is yes. We just zoom in only on x cubed term. So this requires you to think a little. Everyone take a look at this. I need to ask yourself the particular, a very important question. Let's start with the first expression, 5x squared. 5x squared times what over here will produce an x cubed term? Only x, am I correct? This and this. Will 5x squared times anything else here, will it give you an x cubed term? No, only x, am I right? So that is what your focus must be. Let's take a look at the next one, 2x. 2x times what over here will give you an x cubed term? Only, very good, 2x times 3x squared. Only these two, when you multiply together, will give you an x cubed term. Am I right? Let's look at the last one, the constant term. Constant term times anything, will it ever result in an x cubed term? No. So you can drop it, ignore it. So if I want to focus only on x cubed term, basically, therefore, coefficient of x cubed, if you want to zoom in, 5 times 1 plus 2 times 3. So 5 plus 6, 11. You notice you can zoom in straight away without having to expand everything. Okay, that's the purpose of this particular exercise. I just want you to know, if we want to zoom in on a particular term, when we do a product, when we multiply polynomials, there's no need to expand everything, no need. Just zoom in on certain terms will do, and then you'll get whatever you need. Is that alright? Okay, you take a look at this particular example done by Beverly, okay? Over here, if I want to zoom in only on the term that contains x squared, I want to find what's the coefficient of x squared. When I take 2x squared minus 2x plus 5, multiplied by negative x squared minus 3x plus 1, this is what they have. Okay. Theoretically, it looks beautiful, it looks perfect. But is it really perfect? Is it really perfect? What do you all think? Does every one of you have something that looks like this? Okay, let me tell you, this is theoretically, Beverly watch here, don't get shocked. Theoretically, it is wrong. Theoretically, why? Why? Okay, let's take a look. Over here, she says, when you multiply these two, it is equal to this. Answer me, are these two lines really equal? Are they equal? No, they are not, because there are other terms, such as x to the power of 4x cubed, so on and so forth. Am I right? So you know that they're not equal. So what must you do? The trick is to put plus dot dot dot. Then plus dot dot dot. So you know that there are other terms around, but you're not interested in them. Therefore, the coefficient x squared is 3. Okay? So let's take a look at this one by Hannah, done by Hannah. So same thing over here. When you multiply the two expressions, they are not equal only to just negative 6x squared minus 6x squared is not. So there's the presence of the plus dot dot dot, plus dot dot dot, plus dot dot dot. You have to put it. Okay? Then therefore the coefficient x squared is negative 12. Okay, let's take a look at these two particular equations that we have on the board. Question 1 and question 2. Okay, for question 1, right, if we say that x squared is equal to 2x plus 3, and we try to solving this equation, we have x squared minus 2x minus 3 equals to 0. We factorize it. Then after that, we have the value x equals to 3 or negative 1. What does that mean? It means this equation holds true when x equals to what, everybody? Or it will only be true when x equals to 3 or minus 1. X equals to 2, will it be equal? When x equals to negative 5, will they hold? X equals to half, will it hold? No, it will not hold. It will only hold true, it will only be true for certain values of x. Or what we say, for some values of x. For finite values of x. Is that okay? Let's take a look at equation 2. For equation 2, right? Do you know that if you take any value of x, think of any value that comes to your mind right now, instantly. Okay, camera girl, can you tell me, Michelle? Give me one number that comes to your brain. One number. One number. Loud and clear, please. 2. Okay, the number 2. Watch here. If I take the number 2, right? 2 squared equals to 4. 4 minus 2 times 2 is 4 equals to 0. Left hand side is 0. Am I right? Look at the right hand side. 2 minus 2 is 0. 0 times anything is also 0. So you realize that when x equals to 2, this equation will hold. Am I correct? Think of another number, Casey. Any number except the number 2. Quick. 3. 3 squared is 9. 3 squared is 9. 9 minus 2 times 3. 9 minus 6 is 3. Am I right? Let's try here. This is the number 3. 3 minus 2. 3 times 1 is also 3. It will also hold. In fact, if you ask anybody, there are 37 of you in this class. I can have 37 different values, unique values. I take all your values, I plug it inside this equation. Whatever you give it to me, I promise you, the left hand side will be the same as the right hand side. Okay? So what's the difference? Over here, what you see is actually an equation. An equation holds true for some values of x. What you see over here, this, my friends, is actually what we call an identity. Identity. It holds true for all values of x. When we say all, we mean all. Okay? All means all values of x. Whatever value x you throw in, it will always be true. Is that okay? So this is one thing that you have to take note of on what is an equation and what is an identity. To be very, very precise, the symbol for identity is actually 3 strokes. This is actually the symbol of identity. Okay? Have you all seen this symbol before? In one topic in Set 2. What? Louder, Terry? Congruent? Congruent triangles. You learned that in congruent triangles. Am I correct? You all prove that congruent, example, triangle ABC is congruent triangle PQR. Remember you all put congruent? Same shape, same size. It's identical. Identity. Right? So over here, the actual symbol is actually identity. But nowadays, in most textbooks, they don't use this symbol anymore. They just write something equals to something for all values of x. So when you see this particular sentence, okay, this sentence that comes out, okay, this expression, basically it will tell you, my friends, this is identity. It holds true for all values of x. Okay, so now we're going to try to solve for unknowns that exist in an identity, okay? So what's the difference between identity and equation? I said already, equation holds true for some value of x, identity holds true for all values of x. Let's take a look at this particular identity. If I wanted to solve for a and b in this particular identity, I tell you this equation holds true for all values of x. How do we solve for a and b? There's the two unknowns we're trying to solve. Let's take a look. There's a here, there's one unknown, and there's b here, there's one unknown. Am I correct? We're trying to solve for these two unknowns, a and b. When you have two unknowns, how many equations do we have? One. Very good. Somebody said 3 and you got shocked. Okay, there's only one equation here, okay? When you have two unknowns and only one equation, there's only one technique to solve them in a certain sense that you know, comparison. So all you have to do now is to expand this and then we compare. ax minus 2a plus b, so I rearrange this minus 3x plus 5. So over here, if you take a look, this is actually, look, the coefficient of x must be equal to the coefficient of x. See, this holds true for, this holds true, left hand side equals to right hand side holds true for all value of x. That means the coefficient of x must be equal to the coefficient of x. So a is minus 3. Okay, a is negative 3. So by comparison, the term that is independent of x. The term that is independent of x means the term that has no x inside, or constant term. So it's negative 2a plus b. This must be equal to what? The constant term, which is 5. So over here, you replace a with negative 3. So we have 6 plus b equals to 5. B equals to 5 minus 6 equals to negative 1. Is that okay? So this is one approach that you girls know. When you have two unknowns to solve inside one equation, comparison. Okay? Okay, I'm going to show you another technique now, which is called inspection. Okay, what is inspection? Pay attention now. Okay, watch here. See, what is inspection? Inspection is because you know this identity, it holds true for what? All value of x. Am I correct? Means any value of x you throw in, the left hand side must balance right hand side, they must be equal. Okay? So what is inspection? The technique. You use good values of x. You use appropriate values of x. Such that when you put x in, you remove, you eradicate, you pluck out, get rid of one variable. Over here, some of you just now suggest, can I put in 0? Can I put in 1? Yes, you can. But by putting in numbers such as 0 over here, let's take a look. You put in the number 0 over here, you put in 0 over here, replace x with 0. You notice you will still have the a, b and a number. You let x be 1, you plug 1 in here, you have a negative a plus b equals to 5 minus 3. There is still the a, b and a number. It won't solve the problem. Unless you want to construct two equations, solve using simultaneous equation. But a better way is to, example, let x be 2. If you sub x equals to 2 inside, what's the purpose? Watch here. Where x is 2, right? Plug in 2 minus 2 is 0. Notice 0 times a is 0. You already removed the variable a already, the unknown a. So what is left is just b. So calculate what is b. b equals to negative 1. So you just found the value of b equals to negative 1 simply by replacing x with 2. Is that okay? So now you have one last unknown that is left to find, which is a. Now you can put any value of x, any value. So in this case, some of you say, Mr. Can I use 0? Yes. Can I use 1? Yes. I choose 3. Why do I choose 3? Because I'm lazy. 3 minus 2 is 1. 1 times a is 8. So that's the only reason why I choose 3. Okay, so that I don't need to bring down anything as coefficient. Don't need to. Are we clear? So the trick about inspection is to use the appropriate value of x, such that you plug in to remove one of the unknowns to solve the other unknown. Okay? So your homework today, you go home and you try to solve questions. I want you to try the inspection approach.